Okay. First of all, I'm hungry. Second of all, so I've been reading quite a bit about subatomic stuff, particle physics, etc. And I'd heard things that talk about this, and it finally just clicked as at least a possibility, not necessarily as a total belief, but at least a comprehension of concept, or of how it could work if it does work this way, or at least how various ideas can be related together in my head, and me can at least say, yeah, that is a possibility. Okay, so wave-particle duality. I've heard several people say a few things that I think kind of are hogwash, and they just don't understand completely yet. So a lot of things with quantum physics and things like that, I think people like to just say stuff before they understand it very well. Okay, if you zoom in, or if you look at space, not necessarily, not even matter, just space. If you remove all matter from a space, and you look close enough and fast enough, you will see, according to several statements I've heard, you will see particles seem to appear and disappear out of nowhere. That if you could, you can't take a microscope because you can't see them. You can't use your eyes to see it, but you can use instruments to detect it. That apparently you can take instruments and zoom in on spaces, on very, very small areas, and you can see particles seem to appear and disappear out of nowhere. That there wasn't an electron in that area, and now there is. Or there wasn't a proton in that area, and now there is. Or there wasn't a quark, or whatever. Now, I'm not sure about all of the details about that, about which particles appear and disappear, and etc. And there's various counter arguments I've had for that over the years. One is just they're lying, or they don't understand. They mixed up their experiment, and so they're calculating wrong, or they're seeing it wrong. They're like, I don't know, like you measure a half cup, and then you measure another half cup, and then it adds up to 3/4 of a cup, and like, part of it disappeared, when really you just didn't fill up the measuring cup to the right amount, or your measuring cup was wrong, or your other measuring cup was wrong, or part of it evaporated, or cooled and reduced in volume, or whatever. So anyway, operator error or something like that. That's one of my biggest complaints, or reasonings, or arguments against quantum physics theories. Okay, but at least there's this. I came across this one form of comprehension that I would like to at least say. Yeah. So, if you have a surface of liquid, a glass, a cup of water, or a bathtub, or a lake, or an ocean, and you have waves going across it. So you can have waves that are not very disturbed. So you have you throw a single rock in the pond, And you get very clean, clear ripples in circles that concentric circles that just spread out to the edge of the lake. And so you get a nice, clean shape. And then you can do other things. You can have a wave, you can take a wave section, so a section of that circle can look like a line. But then if you have interruptions where different waves intersect on each other, so if you imagine just taking like a glass of water or like a bathtub or something, and you put some kind of vibration on it. Like imagine if you took I guess a paint can shaker would be too much, but if you somehow had something that would just shake the bathtub or the cup of water or whatever, in a very, I don't know, agitate it quite a bit, then you would get all these ripples interacting and interfering with each other, so that it looks like there's just a whole bunch of points, a whole bunch of mountains that just stick up on their own without being really any kind of line or circle or connected shape that form these waves, or that form these form the surface of the water. And if you think about it, if you took if you take a 2D cross section, a 2D plane, and you have it touch, so you have a table that's sitting above the water, and you start shaking the water like this. If you have and you set the table so that it can touch whatever the highest point of the water is. So if you have like a clear lake, then you bring it down and it touches the entire surface of the water all at the same time. Perfectly calm lake, or perfectly calm surface, it touches the whole thing. Then you raise it up and you do a single stone in the middle, and it spreads out from a perfectly clear lake. Then it would draw circles across the surface of that table where it was touching in a circle. And then you could do also a line where a line moves across, and you have bars move across that table. But then if you have the points, and the points are bouncing up and then going down, then you would have this static where you have points here, and then those points disappear. They go down below where you can touch, and then other ones seem to magically just pop up from other locations. But just that kind of explains that one part about matter appearing and disappearing out of nowhere. That if matter itself is a wave of space-time and not a particle, then it makes total sense for a wave is a, I don't know. So what I've tried to say before is that a particle, that doesn't make sense for a particle to totally just disappear and then reappear. But it is totally fine for a pattern to disappear and reappear in a different location. An example of this is, it's really hard. I mean, like, we don't have anything that can teleport a piece of paper from one area to another area. To take a physical piece of paper and just make it appear in another country is hard without it traveling in between the space. But it's pretty simple to take the piece of paper and copy it. And you can do this with other things too. You could take a car and you could take it apart and measure every single little piece and copy all of the patterns of the car, and then you could remake the car somewhere else. So you could have a car in Tokyo, and then you could magically just have a car appear in Chicago without it traveling in between, and the car could be exactly the same, but not necessarily the same car, or almost exactly the same. And so a wave is a pattern of material. So the material, the sheet or the surface, is not disappearing and reappearing. It's not even traveling in the interspace. It is simply being affected by the pattern. And a pattern and a condition can appear and disappear, can change drastically, can morph and shift. But a particle, it would seem hard for it to do that. But if all particles are these patterns or these waves, then that changes the whole dynamic. Then even a particle can be copied, and the medium is space-time, is existence, is this fabric of reality. And so that brings up a few different things. For one, the point idea. So if you have a point of a wave point, a wave mountain, a wave peak, on a two-dimensional plane, I do not know how to isolate a two-dimensional peak. But if you look at it, you could say, so, okay, if you have a 2D surface, you have a trampoline, a sheet, the surface of water, and you have a mound or a peak. So you have a peak on the surface of the water. That peak could, in theory, or not necessarily, not even in theory, that peak could conceivably move across the surface of the water, right? So, like a wave moves across the surface of the water. That the wave falls, and in the front it shoves. So the falling of the back of the wave shoves it forward into the front, which keeps it rolling forward. So there's that. Then some other things. So that falling and rising effect. This brings into there's a few different things. One, how do you get a wave point? Two, how do you get a stabilized wave point that not only doesn't dissolve or spread out or change, that is consistently the same. The wave point stays the same over very different circumstances, and the wave point seems to maintain these circumstances in multiple directions, and then we can explore: is it maintaining those things in multiple directions, or am I just not looking at it clearly enough, or am I not seeing it properly? Okay, so on a 2D surface, you have a wave mountain, a wave peak that's sticking up, and it travels across the surface. So if a wave peak, so if you have a natural wave peak, that's just a high point on the water. That is similar to throwing a rock in the pond. And that wave peak would naturally, on a regular surface, that wave peak would drop in, it would fall into the water itself and raise all of the surrounding, raise the water in the surrounding circumference and create a ripple, and that ripple would spread out. Okay, let's look at antimatter. So if you have a wave peak and a wave valley, so you have a mountain that sticks up and you have a mountain that sticks down. If those two collide, then they would cancel out. And a question being, so they would cancel out, and a question being, how would the surrounding area be affected? Would the water change any? So natural water, I mean like regular surface of water, would be. So I guess this is what you call a thought experiment. Yeah. So the surface of the water, if you have any disturbance whatsoever to the surface of the water, any motion whatsoever, then you have energy that is affecting the rest of the water and spreading that energy around in various forms. If you have any wave whatsoever, even throwing a rock in the pond can create heat and other forms of energy transfer. You could move the water in ways that it causes more evaporation. You could heat up the water. You could cause cavitation. You could cause all kinds of things. But basically, you would be adding energy to the water in the form of heat. Now, with a different situation, with space-time, if you have a fabric that is the fabric of reality, so in one way, you could say that you are heating up, you would be heating up the fabric of reality. And an interesting point would be, if you heat up the fabric of reality, does it expand like matter? If you heat up matter, it usually expands. If you heat up water, so water doesn't really expand, but when it turns into steam, it really expands. But when you heat up plastic, it usually bulges or stretches. When you heat up metal, it expands and stretches. And when you heat up alcohol, it really expands and stretches. When you heat up mercury, it really, really expands and shrinks. And so on and so forth. But if you heat up the fabric of space-time, does it stretch and expand and shrink? Which would be really, really interesting. Yeah. If you heat up the fabric of space-time, does it shrink and expand? The other thing is, if you, by you having, if matter is a wave on the fabric of space-time, that itself would be a deformation of space-time, which would create, not necessarily anomalies, but would create disturbances in surrounding matter. So there's that. This is actually really fun. I like talking about waves. Okay, another one is with water, you're talking about the surface of a material. And with a trampoline, you're talking about a sheet. And then also the other thing is we're talking about a 2D representation of a three-dimensional process. In space-time, you're talking about a three dimensions with time, and then we're talking with the surface of the water or the trampoline, we're talking about a 2D representation with time. So is space-time like water, where you have a surface and then you have depth, or is it more like a trampoline where you have just surface? And what would depth be in a three-dimensional surface? If you have a three-dimensional surface, what would... Okay, so you have a two-dimensional surface with time. And the third dimension is another direction. Okay, so if we do one-dimensional... If we have a one-dimensional surface... one-dimensional surface, a line that is manipulated. Okay, so the two-dimensional surface is manipulated in three dimensions. The one-dimensional surface would be manipulated in two dimensions. And I guess the depth doesn't really matter too much, because you're already using depth for the waves, and anything below the surface of the water could be considered could be just considered below the surface, and anything above the surface could be considered above the surface. So you could, like, in one way you're saying that if you look at just the water, you're saying that there is this block of water with this magical top to it. But if you look at it as a container, like a bottle of water, then you have anything below the surface of the water is one set of material, or so you have the surface of the water as a barrier between what's underneath water and what's on top, air. And then it's basically the same as having just a 2D surface. That you still have a 2D surface, it's just on top you have air and on bottom you have water. Or on one side of the surface you have air, and on one side of the surface you have water. Because, like, you could have bubbles where you've got air under the surface of the water, but it's always air on one side, bubbles or water on the other side. Whereas on a 2D plane or a trampoline or whatever, you would always have the top side and the bottom side. I guess there are some things with... So, technically I think you could replicate everything that a two-dimensional surface can do, water can do. You can have a two-dimensional surface of any kind on water. But maybe there'd be times when it's easier to imagine it as a surface, and maybe there'd be other times when it's easier to imagine it as a container of two fluids. Actually, that'd be kind of fun too. That that you could look at it as a surface, and you can also look at it as the interaction and the boundary layer between two different substances. And then you could also say, so in our example, we're saying that it's silly and impossible for the proverbial water and air to mix. But what if there is a mixture? What can whatever's on top and whatever's above and below the fabric of space-time, the boundary layer, whatever's above and below the boundary layer, can they mix? And does that create something interesting? Okay, so what are all the things? So annihilation, you have antiparticle, matter and antimatter. So you have a wave peak and a wave valley. If you had a real surface of water, and you had a wave peak and a wave valley, or imagine you have a rock, you're holding a rock above the water, and you have an air bubble below the water, and the air bubble below the water wants to float up and create an up ripple of sorts, and the rock you're dropping a rock next to where the air bubble is going to be coming up, and they create a mountain and a valley. And I guess that's not a perfect example, because the air bubble is not going to create. I don't know. Maybe it could, but the rock and the air bubble are probably going to create not going to be perfect opposites of each other. But if you had perfect opposites next to each other, they would annihilate, but as they're annihilating, they would escape, they would spread out a little bit. So for example, so if you had them next to each other, you had the high wave and the short, you had the mountain and the valley next to each other. If the mountain and the valley are next to each other, and you hit play, so like you somehow hit pause, cause a mountain, or make a mountain and make its exact opposite, right next to it, then the sides that are near each other, they will, as the valley falls up or is pushed up by the weight of the water surrounding it, as the water falls into it, it will absorb the mountain, the side of the mountain nearest it, but the mountain will spread out and cause ripples, cause circular ripples, and the valley will cause I actually don't know, can a negative mountain peak wave cause negative ripples? I don't think so. I think it causes ripples. So maybe that. Anyway, if you have two exactly opposite waves next to each other, then they will eventually annihilate. The waves will propagate out, spread out, but the the waves will propagate out. So like you'll have the two circles spreading out, but the circles will be opposite too, and the circles will absorb each other. So the circles will spread out. Wait. And it'll kind of create this big oval, I think. The sides closest to each other will annihilate. And then there'll be this area, this like line where it spreads out, where the circles are getting bigger and bigger. And as they touch, they annihilate. And then they reach each other and they intersect and they annihilate. And so you have this like band that goes on the sides far away from each other. Those sides will go far out in very minor amounts, and then the sides that are facing each other will annihilate immediately, and the sides perpendicular to that line of the far sides will annihilate over a briefer period. Yeah. So, if you look at that, like, energy. Okay, but, so light. If light is motion, or is disturbance of the fabric of reality, of the fabric of space-time. Yeah, I gotta go. I need to use the bathroom.